Now we'll look at factoring three-term polynomials where a is not 1. When I say a is not 1, the leading coefficient is not 1, or we cannot factor out a GCF to make it 1. And so both of these cases, I threw up a couple of problems. Two trinomials, I'm going to try and factor these things. The bummer is a is not 1. Now if they do factor, we end up getting a binomial times a binomial. The method that I'm going to steer you towards is the crisscross method. Why I think it's a great method. Me personally, I learned by the trial and error method. I really like it because you jump to the answer. I still use it. The deal is with the trial and error though, if you struggle with signs at all, if signs are not your thing, and you're like, man, you know, the multiplication of signs, different things, the crisscross method takes that away from the worry away. So it tells you what signs to fill in. So that's really nice. Also, it's very quick. It's almost as quick as just jumping to the answer with trial and error, which is a major advantage over something like the AC or grouping method, we'll call that sometimes. And so all methods are great. I mean, I'm not trying to steer you. If you really like a method, go with it. I mean, my deal is you just need to know how to factor these. I really want you to know how to factor these, but I want to show you as many options as possible. And everybody thinks differently, and if you're like, no, this method's going to be too confusing for me, don't use it. I really seem to have good success when I teach it in class. People really like it. I see people doing really well factoring using this versus some of the other methods. So that's why I feel like I'm trying to steer you towards this one, and I would highly recommend it. But anyways, you run across a problem like this. My first thing when factoring, I'm thinking, okay, GCF. There's no GCF in this problem. Then I recognize it's 3 terms. So I'm thinking, oh man, a is not 1. It's one of the harder ones then. I'm going to have to use one of the methods to solve this. And I'm going to use crisscross method first. So the crisscross method basically says, when you look at this, we'll do exactly kind of what it says. I look at this, I look at the front terms, and I go, okay, what multiplies to be 6x squared? And I'll list a couple factors down here. You can just jump into listing them. I generally will look at the middle term, and I'll go, okay, if it's not too crazy big or too crazy small compared to A or C, if B is like somewhere in the ballpark, you know, it's not like, you know, 50 points or 50 units away from D's or something like that, or just, I mean, sometimes it really jumps out at you, then I'll use closest together factors, like the 3 and the 2 to give you 6 versus 6 and 1. A lot of times when you use the farther apart factors, you get a really big or really small middle term. So I usually use that to my advantage. Just helps save some trial and error process time, but it's not really that big of a deal. You can just jump to it. I look at this, I'm going to list directly underneath it. So I'm going to list 3x and 2x. Doesn't matter which one's first. I know that 3x times 2x gives me 6x squared. I could also do 6x and 1x, but I'm going to choose the closer together ones. Now, I look at the number 28, ignoring signs for now completely, so not looking at negative 20, I'm just looking at the number 28, and I go, what 2 things multiply to be 28? Well, we know that 7 times 4 is 28. Those are the closest together factors. I'm going to stick to that just for the same reason as I stuck to the others. And when I look at this, I'm going to look at this, and you can try and think ahead if you want to, but you don't have to, and I'll show you how you can do that in the future. But I'm just going to stick a 4 and a 7 right there. But why I had to put them here and I couldn't put them as 7 up here and 4 down here, there's a reason for that. I couldn't have stuck the 4 here, reason being you cannot have a common factor within a binomial, or it's not factored completely. If I put the 4 here, this is going to be a binomial. 2 is a common factor of 2 and 4, so I could not stick it here. So the deal is, if I choose 4 and 7, 4 is forced to be here and 7 is here. If you don't notice that first, you kind of stick them in, you just look for that, then really watch for that. And then when I say crisscross, what we're going to do is you multiply always to the right, multiply to the right. It's going to tell you what signs. So I take this one and I crisscross it and multiply to the 7. So 3x times 7 is 21x. 2x times 4 gives me 8x. And I just list them. The arrow's going to the right. So 2x times 4 is 8x. 3x times 7 is 21x. I draw a line here, and I just write what b is with its sign below. And I say, okay, what signs do I need to fill in here so that when I add or combine these, I end up with that exact b? And so I know the signs have to be opposite because that's a negative, and so they would have to be opposite in order to get a negative. Positive times negative or negative times positive will give you a negative. And I can just look at this and go, wait a minute, if I just plug in a negative here and a positive here, and I add those, I get negative 13x. I picked the right factors already and I had them in the right order. I was kind of forced with the 4. So I would just take this then, throw the plus here, take this, throw the minus here. And so my final answer for this problem would be 3x plus 4 in parentheses times 2x minus 7 in parentheses. And notice when I did this, why I couldn't have the 4 there is because then I would have a common GCF and it wouldn't have been factored completely. So that kind of helps you to dictate where to put those. And so you kind of got to watch for that. Sometimes you won't have that case, but when you crisscross them, you end up you can't get this to add up. Then you switch factors, try new factors until it works. But when I say you can start thinking ahead on these, I was thinking ahead and I was going 3 times 7 is 21, I knew, and I knew 2 times 4 was 8, thinking of crisscrossing them, and I knew that if there's a difference there of 13, and so I'm thinking that would be the right one. So, but it takes a little practice, but it can be very fast actually, again, just like the quick way when A is 1, when you get this down really well. And it can save you some major headaches, because if I gave you this problem and I told you had to do it by AC or grouping method, that requires you multiply A times C and then look at the factors of A times C that sum to be B. And A times C is a huge number, and that's going to take you a lot of time. Once you get this down and you really nail this, it's really a cool way to factor, and hopefully you'll like it. I'll do another handful of these just to give you some practice. So let's look at 4x squared minus 19x plus 12. Now this one, I know with 4x, I could go with 2 and 2 as factors, but I'm going to show you, I picked this one on purpose because what if I did this? Because that number doesn't look crazy small or crazy big to me really, so I'm thinking maybe closest together factors. So if I went 2x and 2x, the deal is this is an even number back here. So if I went with 12, there's 2 factors, 4 and 3, can't do it, right? I can't flip-flop them because I'm still going to have a common 2 as a GCF in those. So then what about 6 and 2? Well, they're both even. I'm going to have common factors. Does not work. Can't do it. So the 2 and 2, I can't even use. I'm already forced to go with 4x and 1x, or you can just write x. And so that's already kind of dictated by just looking at, I know I can't have a common GCF within a binomial. Now when I look at this, there was no GCF to take out either, right? And you always have to look at that first. So now when I look for this, I'm thinking, okay, 12, well there's 6 and 2, there's 4 and 3. I'm not sure, I know I can't use the 6 and 2. There's 12 and 1, I could also have tried 12 and 1. I could try 12 and 1 because 1 here, 12 here. That's gonna give me some big crazy numbers though. So I'm gonna try the 3 and the 4. I'm going to go with 3 and 4. I can't put the 4 up there because of a common GCF. Crisscross them. So if you're worried about, man, I just can't figure out what signs to use, no biggie. It'll tell you. Crisscross them. 4x times 4 is 16x. X times 3 is 3x. What signs that are the same sign, when you plug them in here, is going to give you B down here, which is a negative 19x. To combine these to get a negative 19x. Negative and negative, right? So you got it. You just take that. That goes here. That sign goes here. And you just factor the thing. You just write it out. Let's see, I'm kind of running out of space here, so I'm going to write it out here. So I would have, this becomes 4x minus 3 times, in parentheses, x minus 4. And that's your answer for that one. And so you can double check any factoring problem by remultiplying it out, make sure that, combine your like terms, make sure you end up back at that polynomial. And that's it. Make sure you always look for GCF first though in all problems. Look for that first, pull that out, and then treat the polynomial that's left as your problem to factor. But there was no GCF in either of these examples. So I thought I would do one more, maybe two more examples with crisscross just to give you a little more practice on it. But I think you'll see that it works out really nice. So let's do one where it's all pluses. Let's see here. So let's just do one that's like 2x squared. Let's see, let's think of an example real quick. So let's go 2x squared plus 10x. Let's see, plus 13x. And then plus 15. That would be a good one to look at for crisscross. And then I'm just going to give you just where A is 1 example too. One that we factored just to show you that the quick way is the way I would choose with those, but man, that works with crisscross too. I mean, any three-term polynomials you can do with crisscross. So x squared, say, let's see, let's go minus 8x plus 12. That one, we'll try that with crisscross. And so anyways, here's a couple of trinomials. They're both three terms. I'm looking at this one first. There's no GCF within those three factors. So I'm like, oh man, A is not 1, bummer, I can't do the quick way. So I am going to list this underneath. The factors of 2x squared are just going to be 2x and x. I'm kind of restricted on that one, right? 2 and 1 are the only two factors of 2. In 15, I have a couple different scenarios. I have 5 and 3, and I also have 15 and 1. Thinking ahead, if I go 15 and 1, that might seem like it's it. I'm not sure. Like if I look at that, it might possibly be it. But then, by looking ahead with the crisscross, but then you look at this number, you're like, wait a minute, that's a pretty close number to these. So I might just go with the 5 and the 3. Doesn't matter which way because there was no common factor there. So I'm just sticking the 3 and the 5. Now, I like to kind of think ahead on those, so I knew to stick the 5 down here because I'm thinking, okay, 10 and 3 gives me 13. But that takes a little practice. You don't have to, you can just stick them in and try it. Don't even worry about signs or anything. Crisscross these things. And you get 3x. And you get 10x. All right, what same signs will give you that exact positive 13x? It will be a plus and a plus. Dump your signs in and you just factored the thing. And it's really not that bad. And so I really recommend it. It's a great method. If you're first learning factoring for the first time, I highly recommend this method because I just think it's a really nice systematic, really nice method that kind of combines a few different methods, and it's really quick. And so I think you can get really good at factoring and be confident with it. So anyway, so this one right here, I wanted to throw one of these up here because if I gave you this problem, I would expect you, I would actually factor this just a quick way, right? I mean, because I'm recognizing it's a three-term polynomial. A is 1, there's no GCF. I know that if I multiply, if I just jump to the answer, if I multiply -6 times -2, I get positive 12, and if I add -6, -2, I get -8, and so I just fill that in, I'm done. But some people struggle with that. That's a sign thing as well. And if you really struggle with that and you're like, no, if I see a three-term polynomial, I am gonna factor that thing by crisscross. You can do all of them. So I did want to show you one where even if A is 1, you can do it. This is x. And I'm going to use this color here. You know that this is x, this is x. This is, I'm going to try the closest together factors, maybe 4 and 3. If I did that, wait a minute, if I'm thinking ahead, not going to work, right? Because I'm going to end up with 3 x's and 4 x's, 7 x's, not going to get me that. So then I might want to try 6 and 2 or 2 and 6, doesn't matter. And then you try 12 and 1 or whatever, but when you try these and you're crisscrossing, you end up seeing, okay, cool, this ends up being 6x, 2x, has to be same sign. And so the same sign that gives me a negative 8x would have to be negative and negative. Fill my signs in, and you just factored it. And so your answer will be x minus 6, x minus 2. Now I definitely would just jump to the answer, and since a is 1, I know it's x and x, and then what multiplies to be that adds to be that, fills in, it's quicker. But if you struggle with signs and stuff, crisscross, you can always fall back on it. It always works on all of those. So that's 3-term problems. I highly recommend the crisscross. I think it's just a better method if you're first learning factoring. That's it.